Namaste. Today I'm going to talk about my project that I built for Redis Dev Hackathon. It is a URL shortener application where you can have a short URL for long URL so that you can easily share. It also tracks basic metrics like the total hits your URL got and 24-hour and 30 days metrics that you can see how many times your short URL was accessed. Let us see the architecture diagram of the application. The application has two parts, the server and the client. The server is the backend, which is built using Node.js and Express.js, and that uses Redis OM and Node Redis OM and Node Redis packages to connect to and work with Redis. The server as a whole, the backend, runs with a Docker stack, and it's easy to set up using Docker. We will see that in a bit. And the front end or the client application is built with Svelte kit. It's an awesome JavaScript framework. You can check it out at kit.svelte.dev. So how it works is, first the client makes a request, API request to the server, either to store a URL or retrieve a URL or redirect to a original URL. So it makes a request. The server then, using the Redis OM client, connects to the Redis database and then gets the record. Throws an error if the record is not found. Otherwise, it redirects. Or if it is a request to create new URL, it creates the URL and returns back the response to the front end, which is rendered in the browser. So this is the simple mechanism how the application works. Now the application stores data using Redis JSON, as well as it uses Redis time series in order to save the real-time access data or usage data. So the project uses Redis OM Node.js client, where we define a new URL schema. So we only store URL with original URL, the short name, and created date and updated date. And we create a schema using the Redis OM library. We create a schema definition and then we create a repository from that schema. We also create an index so that we can easily search. Now, when adding a new record, when a request is received and everything is verified, we can just call repository.create and save and pass the data so that the repository can handle the rest of the connections. Also, we create a time series data, 3 different time series data for every URL record. One is for real-time hits record that is returned for 28 hours. Another is hourly time series aggregation that is automatically aggregated using this rule here that is defined, and it is returned for 33 hours. And finally, we have a indefinitely retained total hits record that is incremented every time a URL is accessed. And every time the shortcut is used, that is the shortcut URL is accessed, we increment the time series, or we add a new record in the real-time time series and also increment the hits time series by 1. And while accessing the data, we just use the repository to search by short name. So if we want to find the URL by short name, we just use the URL repository that we created earlier and call search by short name, that is the short name provided, and return the first match. So we return the first value that is matched, because during creation we make sure that there can be only one URL with one short name. And then If URL is not found, we throw 404. But if it is found, we increment these time series records and then we redirect to the original URL. And here are other methods for creating and getting usage data, where usage data is aggregated either hourly or daily. So let's move on to how we can run it locally. In order to run it locally, you need Node.js and Docker installed on your system. First, you need to clone the repository and then you need to follow this instruction to run the server. We'll see that live here. You can now clone the project. If you have SSH setup, use this URL. Otherwise, you can use HTTPS best URL and hit clone. Once you clone the project, you can open it in VS Code. Once you open the project, you can see that it has two folders, client and server. First, we need to run the server application, which is built completely on top of Docker. So you need to have Docker and Docker Compose installed locally in order to work with the server. Let's cd into server and then run Docker Compose up-d. Once you run Docker Compose up-d, it pulls up the Redis stack Docker image that we are using in our Docker service, and also it builds our Docker file that we have defined here, which uses Node 16 Alpine. So it pulls the Redis stack, builds our application and runs it. However, we need one more change, that is, we need this environment in order to provide proper Redis URL and other port details. So let's rename this to .env and then we can run Docker up-d again. This will recreate the Redis and our application. Once that is done, we can check that our server is working by doing compose logs app. This will show that our server has started at port 8000. Okay, we are all set with our server. Next, we need to set up our client. So let's cd into client. Our client is built using SvelteKit. If you want to learn more about Svelte and SvelteKit, you can go to svelte.dev. Now, in the client, we need to run npm install. Make sure you have Node.js and npm installed in your system in order to work with the client application. Also, here we need an environment variable, that is the server base URL, so that our client can talk to the server. Let's rename this env.example to .env. And once the npm install is complete, we can run our client and see it in action. Okay, the npm install has completed. Now we can run npm run dev. This will start our application in a dev server. Let's visit our application. So here it is running. If we go to URLs, no URLs found. So let's go back. Let us add new URL. Let's give it an alias of Google. Let's tap certain. So it should create our sort URL, which is localhost 8000-/Google. Well, it's long, but that's fine. Now, if we go to list URL, we can see it here. And if we see, we have a QR code for this example, and we can copy this link and paste it here. It should redirect to google.com. As you can see now, we can add more like this. shorten, and we can copy this, see it here, it redirects. We can directly click on the link here, again it redirects, and if we tap on the details here, we can see the users graph. So it has total hits of 2, that is the URL was used or clicked twice, and then we can see the chart of last 24 hour or last 30 day. The last 30-day one is not showing the data for current day because it is aggregated every hour using Redis. So we can see how the data is stored here in the server as well. If we go to server app, in the OM, we have client that uses Redis OM and Redis package, Node Redis and Node Redis OM packages in order to connect to Redis and Redis stack. And then here is a URL schema that we are using to save our data. So the schema has original URL, which is a string, short name, which is also a string, created at, updated at, which is a date. And if we go to routers, URL router, we can see bunch of methods here. For example, every time we get a URL, we also create, so where is it, get URL, we also add a time series data, okay, and then we are also adding another time series data which is always incremented by 1, that is total hits is counted in one time series and the actual usage data is calculated in one time series. If we go to where we create our URL data in the router post, when new URL is created in the repository, we add a new URL using URL repository, and then what we do is we create a time series with URL entity ID that is retained for 28 hours. This keeps every matrix that is added for last 28 hours, and then there is another time series that is hourly that keeps the data for 33 days, and we create a rule. So we also create another time series for total hits lifetime. We do not set retention because we want it to be retained always. And finally, we have a create rule. What it does is it aggregates data from this time series data into a hourly sum. So every hour it aggregates this data so that we can easily calculate daily usage data using this hourly data. So our hourly data is calculated using this time series in the runtime, whereas our daily data for last 30 days is calculated using this hourly rule, hourly aggregation, so that it is easier and it is retained longer. So we only get data after 1 hour. Okay, so this is how it works. We can see the data in the Redis Insight. So let us see. Our Redis Insight should be running in, if we look at Docker Compose, the Redis Insight should be running in port 8001. So if we go to localhost 8001, we can see our Redis Insight. Let's just accept, and we can see our data here, our time series hits, see, and then our JSON data for each URL. This is for google.com. This is another time series, okay, and here is hash for URL so that we can implement searching. Then we have this hourly time series which is aggregated every hour. Then this we have another time series for another URL and hourly aggregation for another URL. So this is how the data is stored in Redis stack. So that's all for this project. I hope you like it, and this is available in GitHub. You can clone it, you can build on top of it. It is available with MIT license, so you can build a product out of it. So thank you. Have a nice day.